All right, so today we'll be going over the chain rule. And a chain rule is an extremely useful trick for calculating the derivative. It's a pretty common one, so you guys got to make sure you become familiar with this and pretty comfortable with it. So essentially using the chain rule when you have a function inside a function. So if you have some function, but you have another function inside of that. So like here's an example. Let's just say like you have x squared plus 1 squared. In this case, you have a function inside of a function. You have this function of x squared plus 1, and then you have that function, the whole thing being squared. So the way I like to denote it is having my inside function equaling u. So u, in this case, is going to be equal to x squared plus 1. And we could say that f of u is just going to be equal to u squared, right? Because if we substitute this in, it's just going to be the same as that. So you have to use the chain rule for these kinds of problems. And so the way we could prove this works is by if we take the derivative of y with respect to u. So in this case, we're taking the derivative with respect to u, and we multiply that by the derivative of u with respect to x. And in that case, this one is going to apply to this one, because we know we're taking the derivative of u with respect to x. And in this case, let's see if I can draw that line. We're taking the derivative of this function. And when we multiply this out together, we're going to get dy du over du dx. The du's cancel out, and we're just left with the derivative of y with respect to x. So we're able to get the derivative of the whole function. However, to do so, it requires us finding the derivative of u and the derivative of f of u. And so I think that may be a little confusing. However, I think an example can really illustrate this point pretty well. So let's just solve this one. Let's just solve, we want f prime of x of f of x equals x squared plus 1 squared. So we said our u is going to be equal to x squared plus 1, and our f of u is going to be equal to u squared. Now we know the derivative of u is just going to be equal to 2x, and in this case, our derivative of f of u is just going to be equal to 2u, according to our power rule, and hopefully you guys watch that video. So when we multiply this all together, we're going to get, we're going to be left with 2x times 2u, and then we can substitute what u is. So we're left with 2x times 2x squared plus 1. So we're left with 4x x squared plus 1. And then we're left with 4x cubed plus 4x. Or either way is fine. However, we know that our f prime of x is going to be equal to either that one or that one. It's the same thing. It's just simplifying. But yeah, so essentially what you're going to do, find a derivative of the inside function, and then find a derivative of that function that encompasses. So in this case, u is our inside function, and f of u is just simply u squared. You find a derivative of both, multiply the two derivatives of each times each other, and then you just substitute u in for this u right here. So relatively straightforward, and eventually you can start doing this in your head. However, take some practice, but yeah, so let's just do another example. Let's say we want f prime of x, we want the derivative of f of x equals 3x minus 2x squared all raised to the 6th. So I suggest you guys try this one out yourselves, and I'll show you how to do it. So our inside function is going to be u, so we know u is going to be equal to 3x minus 2x squared, and our f of u is just all of this raised to the 6th, so it's just going to be u to the 6th. And so we know u prime, the derivative of u, is just going to be 3 minus 4x. And then our f prime of u, our derivative of f of u, is just going to be equal to 6u to the 5th, according to our power rule. And then we just simply multiply these together. So 3 minus 4x times 6u to the 5th. And then we could just substitute. So 3 minus 4x, 6. And then we substitute u in. So 3x minus 2x squared to the 5th. And this is what our f prime of x is going to be. You can simplify this more, but however, this is what it's going to be equal to. And so let's go over another example. And even though in all the examples we've done, it's always been something in parentheses, raised to some power. However, this also applies to square roots. Because if we have the square root of some function u, this is the same thing as u to like u to the 1/2. So it's the same thing. So this is also going to come up a lot in square roots problems. So I have two examples for you guys there. So let's just say we want f of x equals the cube root of x squared minus 1 squared. So in order to do this problem, we can rewrite it a little bit. So we know f of x is going to be equal to x squared minus 1 to the 2/3, right? Because we can eliminate the square root just by making a fraction between the square and the cubed, and the cube root right here. So this is going to be, it's the same thing. So we know our u, our inside function, u is going to be equal to x squared minus 1, and our f of u is just going to be u to the 2/3. We know u prime is just going to be 2x, and the f prime of u is going to be equal to 2/3 u to the negative 1/3. And then we can just multiply these together. So we have 2x times 2/3 u to the negative 1/3. And then we can just substitute this u back in. So f prime of x is going to be equal to 2x 2/3 x squared minus 1 to the negative 1/3. Or we can simplify that, and overall it's just going to be equal to 4x divided by 3 x squared minus 1 to the 1/3. And there you go. That's all there is to it. Sometimes it may require a little bit of manipulation of the equation using some algebra to simplify it. However, that's all there is to it. And then we could do another example. So let's just say we want f prime of x of f of x equals negative 7 over 2x minus 3 squared. So in this case, this one also requires a little bit of rewriting. So we could say this function is also equal to negative 7 2x minus 3rd to the negative 2. Because remember, we can bring this up, but we have to make the exponent positive. So in this case, our u is going to be equal to this inside function. So u is equal to 2x minus 3. And our f of u is going to be equal to negative 7 times u to the negative 2. And you could also do this if you have a coefficient in front right here. It doesn't really change anything, as this is just still a function of u. So our u prime is just going to be equal to 2. And our f prime of u is just going to be equal to 14 u to the negative 3. And then we can multiply this all out together. So we're 2 times 14 u to the negative 3, which just becomes 28 2x minus 3 to the negative 3. And we can further simplify this as f of x is equal to 28 over 2x minus 3 cubed. And there you go. That's all there is to it, to the chain rule. And just remember, you got to use this when you have a function inside of another function. And yeah, it's going to be a pretty useful rule.